Now I'd like to introduce our Singapore math expert, Shar Forston. Shar has been a teacher and a principal. She's the author of several books on Singapore math. She's been the featured speaker at conferences across the country, and she's helped thousands of teachers develop the skills and the confidence to teach Singapore math successfully to their students. It's my honor to introduce Shar Forston.
Good afternoon, everyone. It is such a pleasure to share what I have learned from Singapore math this afternoon. And as you can see, these smiling faces of students from Singapore in front of you, the main question becomes, why the interest in Singapore math? Because this small island state country went from low performing in mathematics globally in the 80s to a very, very high performing nation in the 90s and of course today. So in this short time together, what I'd like to do is to share some of the benefits reported by schools that have adopted as well as those schools that are simply supplementing their current math series with Singapore math. I want to share the benefits, and more importantly, I want to share some of the strategies. So first of all, as you can see, what is really important to today's age is to encourage algebraic thinking. Throughout their primary curriculum, which is through 6th grade, they develop algebraic thinking through their strategies. They reduce complexity. Students learn how, but more importantly, they learn why before they learn how. And along with that, they move more slowly through topics, always for mastery, and it promotes a deeper understanding of these essential math concepts. As you'll see today, they definitely enhance problem-solving skills. We're going to look at one particular type of method they use called model drawing today. It is a very visual approach, and it helps students focus on the problem with word problems. Also, I think as we go through this, you'll realize that it helps all students either as an intervention strategy to support struggling learners, for those of you who teach the older students who maybe didn't get that strong foundation in the younger years, and also a number of schools use some of the strategies as extension ones to challenge gifted and talented. And this question frequently comes up. I mentioned it earlier, but I want you to be thinking about this, that it is effective as a standalone curriculum or as a supplement to an existing math series. So these are the benefits. What I'd like to share now are some of the features. What makes these benefits possible through Singapore math? Well, one thing I want to share in this brief introduction is when they created their math curriculum in the 1980s, they actually looked to the United States to see how to best teach mathematics. And they focused especially on Jerome Bruner's work. And Jerome Bruner said that children learn mathematics best, deep understanding, when they go through a concrete, pictorial, abstract approach, a sequence. Now, in Singapore, they call this CPA. And what do I mean? Well, as you can see in this picture in front of you, you have narrators. This was a 2nd grade class in Singapore, and the teacher had divided her class into 3 groups. In the narrators, and you can see the arrow, and those are the students that are going to be naming these groups for multiplication. You also have, for the concrete stage, actors, and these are students who are actually creating the equal groups. And then she has, for the pictorial stage, illustrators, and these are students drawing diagrams of the groups. And in her lesson plan that day, she had listed background knowledge was that these students in primary 1 or 1st grade had learned repeated addition. They introduced multiplication as creating equal groups as a more efficient way to do repeated addition. So this is her whole lesson on following Jerome Bruner's CPA approach. So she would say, ready, set, action. The narrators here said, show us 2 groups of 5. The actors got into 2 groups of 5. The illustrators drew a diagram. This next slide shows the narrator saying, show us 5 groups of 2. Again, they got into their new groups, and you can see those busy beavers back there illustrating these diagrams. And following this, so your concrete pictorial, the abstract, and the abstract level is truly writing numbers. That is abstract, using symbols to represent numbers. So what they did in small groups, they took the diagrams and wrote multiplication sentences for the examples that they had seen. So One feature is their constant reliance on thinking CPA, concrete, pictorial, abstract, to bring about their benefits for deep understanding. As I considered today, too, another key feature, something absolutely foundational in Singapore math, is called a number bond. We call it a math family, fact family. But it encompasses part-whole thinking. And the research is very strong that when children learn part-whole, it helps develop their algebraic thinking. It helps develop later their understanding of fractions and rational numbers. So number bonds are to help students both compose and decompose numbers, as well as understand something I'm going to show you today, a strategy called compensation and addition. So you can see on your screen that I have a math sentence, 8 plus 5. First of all, the entire first semester of first grade in Singapore, those first graders learn number bonds to 10, all the different ways to make and take apart 10. So they would know when they look at the 8 and the 5, they would have mastered all the different ways they can put those together and take them apart. Then they actually would have used at the concrete stage manipulatives. Maybe they would have had 8 craft sticks and 5 craft sticks, and they always made a group of 10. And so they bundled the 10, so they would see 8 plus 5 is 8 plus 2 from the 5 to make 10 plus 3. But I'm going to show you the pictorial stage. And in a lot of textbooks in the States, we call this compensation. So a child looking at this now is thinking mathematically. They look at the 8, and they think, what do I need to complete a 10? Well, they need 2 from the 5. And the other part that's left is the 3. So a student doing this pictorially, and this is the diagram, is 10 plus 3, or 13. Some of you will see this called branching in many U.S. books that talk about Singapore math. But picture a student doing the diagram. This eventually leads to the abstract level of being able to do it mentally. So they would do this with the single-digit numbers. They would do it with 48 plus 5 later on, 298 plus 5. But then they extend it into the more complex areas of adding, say, units of measure. And so this example, for a lot of American teachers, we know that we would add these two together, get 20 ounces. And then what do? We teach children to convert. And that is really dividing, and it becomes a procedure. But let's look at an intermediate step. And again, compensation or part-whole thinking. So a student would do this, 14 ounces plus 6 ounces. They're now at a, we're a few grades higher than first grade. And they would realize, I'm going to get 20 ounces. I'm going to go over 1 pound. So they start to think, okay, much like we did the number bond before. Now, my next unit of measure is 1 pound. So the student thinks, how many ounces from the 6 do I need to complete a pound? I need 2 ounces. And then what's the other part that's left? 4. So what do I have? I have 1 pound, 4 ounces. This is a step used in between adding under ounces less than a pound and before converting units of measure. So this part-whole thinking is very valuable. It builds understanding. They also use it, they use it for adding time, units of time, inches and feet, all of that. Complete one whole unit and then what's left over. But I want to show you one more example that I believe to be very, very powerful. And now picture we're adding 5/7 plus 4/7. Typically what we do is we would get an improper fraction. We would get 9/7. And once again, what children learn to do as a procedure, they learn to divide 7 into 9, and they get one group, and they get 1 2/7. So what I mean is this is the procedure to convert an improper fraction to a mixed number. I want you to watch an intermediate step here again, emphasizing mathematical thinking. Now a student realizes they're going to go over 1 whole unit of 7ths. So they're going to ask, how many 7ths do I need from 4/7 to complete 1 unit? I need 2. So how many are left? 2/7. So I have 1 2/7. understanding versus simply doing a procedure. So one thing this afternoon, one feature or strategy I wanted to share was this idea of using number bonds through the grade levels, if you will, to reduce complexity and emphasize understanding. That was for addition. Another strategy they use that I want to share with you has to do with subtraction. And of course they learn they learn multiple models. They use Zoltan Dienst's philosophy of multiple models to understand different concepts. But now they're at the point in third grade where they're subtracting 3,267 from 5,000. They've learned the algorithm. They've learned why the algorithm works, so they know why it works and how it works. But a child with true number sense would look at this and say, this is going to get me into serious trouble, subtracting across zeros. So watch again what would have happened in earlier grades. Something like this with single-digit numbers. I might, with a young student, say, well, let's subtract, and if we take 4 from 6, the difference is 2. And then what I might do is to say, well, let's add 3 to the minuend and 3 to the subtrahend. And what do we get? 9 take away 7. What's the difference? Still 2. Well, let's subtract 4 from the minuend, 4 from the subtrahend, and we now get what? 5 take away 3. And what's the difference? 2. Why am I sharing this with you? Because this is what takes place earlier, where children actually themselves come up with a rule where it doesn't matter, you do not change the difference when you're subtracting as long as you add or subtract the same value to the minuend and the subtrahend. So once they see how this works, watch how we can apply it to a problem later on. A student with number sense would say, guess what? I know a better way. If I subtract 1 from the 5,000, I now have 4,999, which means I must also take 1 from the 3,267, so 3,266. What I've created is a much friendlier number, 1,733. I had a teacher recently come to an event where I was speaking and tell me that her school went up an entire stay line just based on this one strategy. But it's not a trick, and I hope you see that. The other example of subtracting with compensation is, and I'm going to show you one. Many teachers, again, if you're watching this, you're going to know this student because I taught them myself. 23 take away 18. Children who only learn procedures see the subtraction sign, and usually this is what they'll do. 1 from 2 is 1, 3 from 8 is 5. And what I always say on a multiple choice exam test, this will always be an option for students to answer. So typically this is what can happen. But watch what we're going to do. I'm going to show you, again, using that earlier rule that they have discovered with single-digit numbers. They would look at this, and I'm not subtracting, I don't have zeros, but I am regrouping. So they're thinking. And you know what? What they would have known, too, is that if I'm subtracting a multiple of 10, it's much more friendly to subtract. So what do? If I add 2, I can then change the 18, add 2, and get to 20, which means I must also add 2 to the 23 to get 25, and my difference is 5. So these are strategies that are developed very, very carefully and sequentially. And I thought that those would be very helpful for you to see in an introduction.